All right, now, as you see this big, ugly fraction, basically fractions within fractions, a great way to be able to deal with this is actually think of it as a division problem. Because really, that fraction over a fraction means the same thing as the fraction divided by the fraction. So I'm going to be doing negative 1/2 divided by negative root 3 over 2. Now, every now and then, some people get thrown off by the negatives and, like, where does the negative go? Does the negative go into the top, the bottom, or does it go into both? Well, it goes into the top or the bottom, but not both. If you put it into both, you'd have a negative over a negative, which would cancel out and become positive. So either one can be negative. Now I just make a habit when doing these operations, I'm just going to go ahead and put that negative into the top of each fraction. And that way it makes it a little bit easier. From here, we can go ahead and do the fraction division. Now, how do we divide fractions?
Multiply by the reciprocal.
Yep, multiply by the reciprocal. And so I basically flip the second fraction and turn it into multiplication at the same time. That's all one step where we flip it and multiply. Remember, you always flip the second. No matter what it is, you flip the second fraction. So now that I set it up as a multiplication problem, I go ahead and multiply the fractions. Remember, in order to multiply fractions, I'm just going to multiply straight across the top and straight across the bottom. Now when we do that, we get negative 2 over a negative 2 root 3. This can obviously reduce, right? Because I can divide both top and bottom by that negative 2. The negatives cancel out basically and the 2's cancel out. If I do that, that leaves me with 1 over the square root of 3. Which certainly is much simpler, but it's actually not simplified. Because remember, we actually are not allowed to leave a square root in the denominator when it comes to actually writing it as simplified. So, remember how we get rid of the square root of 3 on the bottom? I multiply top and bottom by that same square root of 3. Remember, this is the process called rationalizing the denominator, because we're turning the bottom of the fraction into a rational number. And root 3 is irrational. All right, and so if I do that then the 1 times the root 3 on the top is going to give me root 3. And the reason why we multiply by root 3 is because root 3 times itself on the bottom, that just equals 3. And so this then gives me an answer of the square root of 3 over 3. And then this, that is as simplified as we can make it, so we're done now. So now let's take a moment and check that assignment from yesterday. Because yesterday we filled in the whole unit circle, and then I said, okay, now use the unit circle to fill in the sine and cosine values in this table. You should be able to take them directly from the unit circle picture, sine being the y coordinates, cosine being the x. Now, we're going to be using that work that we did in the unit circle yesterday and that table of values that we've created to be able to figure out these values now without using a calculator. Today we're going to see how we can find the values of tangent. And we'll start with the tangent of 135 and 210 degrees. But we need a technique here, right? I'll put these problems back up here in a minute because we need to see how to approach it. So here's our basic unit circle, right? And this is assuming we're going from our central angle here or this angle. They'll both actually be able to tell us the same sort of information. So if we want to know tangent, well, what's the general definition of tangent again?
Opposite over adjacent.
Yep, opposite over adjacent. Now notice, then, I'm using these two side lengths here. But we know another way to find those two side lengths, right? How do I find the adjacent side length? Well, that's like my x-coordinate, right? What do we use to find the x-coordinate?
Cosine.
It is cosine, yeah. So to find the adjacent, I do cosine. What do I use to find the opposite in this sort of a problem?
Sine.
It's the y-coordinate, so yeah, it's going to be sine. So I could have just as easily labeled my picture like this, which notice then leads us to something. Because if tangent equals opposite over adjacent, and these are what the opposite and adjacent, then I know that tangent also equals sine over cosine. And this is actually a definition that we can use in general going forward. So make note of that tangent equals sine over cosine. And then there's actually one other cool little perk about this though. Because we did this based on the unit circle work we've done, where we've seen that it's sine over cosine. But you'll notice that because this is tangent and it equals opposite over adjacent, the hypotenuse length didn't enter into it. And since the hypotenuse length was unrelated, the fact that it was a unit circle actually isn't even necessary. This definition of tangent works always. Tangent will always be sine over cosine, and not just if we start with a unit circle. So now knowing that, we can go back to our problems that we're trying to solve without a calculator here. We can find the tangent of 135 degrees now because I know what sine and cosine of 135 degrees are. We're going to be making use of that table now. So for tangent of 135 degrees, I can go back to my table, find 135 degrees, and I can grab the sine and cosine values there. And so if tangent is sine over cosine, well, sine is root 2 over 2. Cosine is a negative root 2 over 2. So that's how I can find tangent. Root 2 over 2 over a negative root 2 over 2. Now, if we want to actually figure this out and actually do the math on it, remember how we did that problem at the start of class today. Turn into division. So we're dividing the two fractions, and then we can flip and multiply. But you'll notice that when we do that with this particular problem, I end up with root 2 over 2 times a negative 2 over root 2. A lot of stuff ends up multiplying through and canceling out, because that's just going to give me negative 2 root 2 over 2 root 2. Which actually we could have seen coming, because notice in my fraction here I have the same thing on the top and bottom, just the top was positive and the bottom was negative. So of course anything divided by itself is 1, and anything divided by its opposite is negative 1. So then we can now know that the tangent of 135 degrees equals negative 1. Now, for the second problem there, we're doing tangent of 210 degrees. By the way, notice there was no parentheses in the first problem over here, around the 135. I do have parentheses around the 210. What does that change? Nothing. You can include the parentheses or not include the parentheses. It means the exact same thing. Why did I do it that way? Just to point out that it means the exact same thing. All right, so if I want to know the tangent of 210 degrees then, I'm going to go over to 210 degrees in my table. And I know that tangent equals sine over cosine, so I'm going to take the sine value on top, and I'm going to take the cosine value on the bottom. And so we have a negative 1/2 over a negative root 3 over 2. What does that equal? Oh, do we not know? Well, let's take a look. What would the work look like? Well, I turn it into a division problem, and then I'd flip and multiply, which then gives me 1 over root 3 when I reduce it. And then I got to rationalize the denominator. Yeah, this seems familiar, right? It's almost like this is the problem that we started class with. This is why we started class with this particular problem, so that we could have some practice on it before we had to be thinking about that and the idea that it's tangent all at the same time. But that means that we now know what the tangent of 210 degrees is. So now we know a couple of the values. We can fill those two values in on our table. Well, and if you can fill in those two values, you can fill in all of the other values. So, please do so. Fill in all of those tangent values without a calculator. So, we know these two values I've written up here already. Let's take a look through each of these. You're going to find that as we take a look down these, a lot of them are actually going to be very easy. Like the first one here at 0 degrees. 0 divided by 1. 0 divided by 1 is 0. Okay, that's easy, right? The next one. 1/2 over root 3 over 2. That is also easy because we did a negative 1/2 divided by a negative root 3 over 2 back here. The only thing that's changed is the signs. And actually, since a negative divided by a negative gave me a positive, and in this case we're doing a positive divided by a positive, it's also going to give me the same thing. It's going to give me root 3 over 3. Doing the exact same thing that we did on that problem earlier in class. 45 degrees. Well, that's root 2 over 2 divided by root 2 over 2. That is, it's root 2 over 2 divided by itself. And anything divided by itself equals 1. Okay, 60 degrees. Root 3 over 2 divided by 1/2. Well, we haven't done this one yet. It'll require a little bit more work, so I'm going to come back to that one here in a moment. It's not too bad to do. In fact, it's easier than the one we did earlier, but I want to come back to it. 90 degrees. There we have to do 1 divided by 0. What's 1 divided by 0?
Non-existent.
This is the tricky one.
0.
Yep, it's undefined. We cannot divide by 0. It's impossible. If you have 1 apple and you want to divide it up into 0 pieces, you can't. There's always going to be some pieces. All right. Then, 120 degrees. That's the root 3 over 2 over a half situation again, kind of like 60 degrees was, so I'm going to come back to that one. And then we already did 135. 150, that's 1/2 over root 3 over 2. Just like 210 degrees was. The only difference is the signs. Well, if a negative over a negative gave me a positive, in this case it's a positive over a negative. So it's going to give me a negative. Specifically, a negative root 3 over 2. I'm sorry, root 3 over 3. 180, we're doing 0 divided by negative 1. That is 0. Yes, if we have nothing and we cut it up into a bunch of pieces, we still have nothing. So it's okay to divide 0 by a number, just not divide by 0. All right, so notice we've already filled in so much, and by using that same process, at 225, I get positive 1, because the negative divided by negative is positive. 240, we'll come back to it. 270, can't divide by 0, so it's undefined. 300, we'll come back to it. 315, a negative divided by a positive is a negative, and otherwise it's the same thing divided by itself. 330, that one's like the 210 that we did earlier, because it's 1/2 over root 3 over 2. So we know we're going to get root 3 over 3, and then it's just a question of negative divided by positive, give me negative. And 360, 0 divided by 1 is 0. Notice our values for 360 are the same as they were for 0 degrees, because it's still one full revolution around the circle. All right, so that gives us just one last piece. We need to do the root 3 over 2 over 1/2 and figure out what that one equals. All right, now to do that work, again, set it up as division. So we do root 3 over 2 divided by 1/2, which is going to be the same thing as root 3 over 2 times 2 over 1. And so after we multiply, we get 2 root 3 over 2. And notice if I have 2 root 3 over 2, the 2's cancel out, and I'm just left with the square root of 3. And so then that gives us that value. By the way, little side note here. That's how we do it using that same method, but I want you to just notice one other little detail here. The value that we found earlier, doing like the 1/2 over the root 3 over 2, and this one, the root 3 over 2 over 1/2, notice it's the same numbers, it's just which one's on top, which one's on bottom. So actually, I could also have gotten this root 3 by taking the root 3 over 3 that I found earlier, and doing 1 over that, taking the reciprocal of it. Remember, in the middle of that problem, it was 1 over root 3. If I flip that, I get root 3. Just another way to see some of the symmetry in this. So here's a cleaner version. Go ahead and make sure you have all of those answers correct in your table so that you can use them going forward. As you do so, make sure that you got the negatives actually marked as negatives. Today we're also going to be looking at radian measures of angles. And so add this into your notes. So radians are just another way of measuring an angle. Think of it as degrees is a way to kind of measure inside the angle. You know, we're seeing, okay, just how far open are the two lines. Whereas radians are more a way of saying, if I start at 0 and then start tracing around the circle, how far will I have actually traveled? It's just a different way of thinking about measuring an angle. But in reality, they're just different units. It's like feet and meters, that sort of a thing. And so a few little details here about these radians, things that come up. First of all, because a radian measure is the length of the arc of the unit circle has a radius of 1. And so then a full circle, if I go all the way around it then, that would be 2 pi radians, because the circumference of a circle is 2 pi r, and our r here is 1. So because of that, and I'm jumping down to the bottom here for a moment, that's why in this formula here, why we have the 2 pi. Because a full circle is 2 pi in radians, and a full circle in degrees is 360 degrees. So that's why we have this formula being what it is. The question often comes up, what is a radian? A radian isn't necessarily anything in particular. It means you happen to have traveled the arbitrary choice of 1 unit around the outside of the circle. 1 radian isn't something that comes up a lot. Things that come up a lot are things like pi radians, 2 pi radians, pi over 2 radians, things like that. And so we're going to use this formula then down here to convert between degrees and radians. Now, there's other formulas that you'll see out there if you forget it and like look it up online or something, because a lot of people will reduce this. But I think that I would rather have you memorize it this way because it's more intuitive. Because this formula here is basically saying you have the full circle on the bottom. And all you have to remember is that there's 360 degrees in a circle and there's 2 pi radians in a circle. And if you know that, then you just put what part of the circle do I have on the top. And we put it over the full circle, 360 or 2 pi. And we'll see how to use that in a couple example questions now. So we're going to work through both of these questions and see how do I take the degrees and turn them into radians, or how do I take the radians and turn them into degrees. And so my general formula, again, remember, it is d over 360 equals r over 2 pi. When using this formula, I'm plugging in whichever one I have. Now notice in this first problem, I start with 135 degrees. So that means I'm going to take that 135 and I'm going to plug it in for the degrees, d. And so then I'm going to write 135 over 360 equals r over 2 pi. And from here, it's a proportion, which we can solve by cross multiplying. So I'm going to go ahead and do 360 times r. Well, that's just going to be 360r equals the 2 pi times 135. When I do that, that gives me 270 pi. All right, now remember, I'm still trying to figure out what the radians is. I'm trying to solve for r. So in order to do that, I want to divide both sides by the 360. Because then that leaves me with just r equals on the left-hand side. That's our goal. But now on the right-hand side, I have 270 pi over 360. Yes, I do need to reduce my answer here. And so, what can I divide both 270 and 360 by? Well, it depends on if you see the biggest right away or not. If not, notice they both end in zeros, so I could cut those zeros off by dividing by 10 right away. Then it's 27 over 36. I can divide both of those by 9, because I could divide the original by 90, as it turns out. Either way you think about it, though, you're going to end up getting an answer of 3 pi over 4. Once it's reduced, that's your final answer. And yes, we want to leave it as a fraction, and yes, we want to leave pi in there. Now for the second one here, we have 7 pi over 4. I still am going to start by using the same formula. I still start with d over 360 equals the r over 2 pi. But then I need to take my 7 pi over 4 and plug it in. In this case, 7 pi over 4, notice there's no degree symbol up here. There's a pi in it. Both of those tell me that it's the number of radians. Technically, if there's no degree symbol, we can know it's radians, but every now and then we get a little sloppy. So pi is also another indicator, another hint. All right, so then I'm going to go ahead and plug that 7 pi over 4 in for r. Notice we're doing a lot of problems today that have fractions within fractions. That's okay, we know how to deal with it. In this case, once I've plugged in either my d or r value, depending on the problem, I actually do the same thing. I cross multiply at that point. But then that means I'm doing the 360 times the top of that fraction. So I'm doing the 360 times that 7 pi over 4, which got a little sloppy, so I'm going to redraw that in. There we go. Now if I do 360 times 7 pi over 4, that's like doing 360 over 1 times 7 pi over 4. So I'm going to do 360 times 7 pi on the top, and I'm going to do 1 times 4 on the bottom. Well, what's 360 times 7? So on the top then, that's 2,520 pi over 4. Does that simplify? I mean, I'm hoping that simplifies. Does that simplify? What's 2,520 divided by 4 give us? And so we get 630 pi when I cross multiply like that. Basically, the idea, if you want to shorthand that, is we multiply the whole into the top of the fraction, and then we divide by the denominator, assuming it's divisible. And of course, leave the pi in there. All right. And then, next up, we cross multiply going the other direction as well. So I now do d times 2 pi. That's a little bit simpler to do. That's just going to give me 2 pi d. And now again, I'm remembering that I'm solving for the variable. I'm solving for the unknown, which in this case is d. So that means in order to get d by itself, I'm going to divide both sides by whatever is multiplied by d. That is 2 pi. And yes, I can divide both sides by 2 pi all at once. I don't have to divide by 2 and then by pi in separate steps. And so if we do that, on the left-hand side, I do 630 divided by 2. That gives me 315. And then I do pi divided by pi. They just cancel each other out and go away. That's awfully convenient on these. And then that just equals d, which means I'm done. I figured out that d equals 315. So the answer is 315 degrees.